All right, so hello everyone. Welcome to our second keynote for Capsule Hack. Want to introduce Shah Selbe. Shah is an engineer, conservation technologist, and National Geographic explorer that works with communities, NGOs, and developing countries to identify and deploy technologies that actually help with our greatest conservation challenges. And that includes low-cost observation platforms, conservation drones, acoustic sensors, open source sensors, and better methods to share and manage the data gathered. He founded Conservify in order to bring open source technologies into conservation. And with that, I'm really excited to have Shah talk with everyone here today. I know that we're in the midst of our hackathon, so I hope that this talk is extremely inspiring and encouraging to you. Couple quick housekeeping items. We have no live Q&A, so if you do have questions for Shah at any time, go ahead and type those into the Ask Speaker Questions Slack channel. And after the session, we'll be there floating around and Shah will answer those, as I'm sure as many as he can. But for the rest of you, for the recording and for other participants, we will ask that everyone be muted. If you're currently not muted, we will, on the back end, actually mute you. So with that, Shah, I'll hand it to you.
Great. Hi, everyone. As you heard, I'm Shah. I'm going to pull up a presentation and talk to you a little bit about my journey and what we do at Conservify, conservation technology, and kind of how to find your path. So give me 1 second. Let me pull that up. Okay. Can you guys see it?
Yes.
Okay, great. All right. So, as you heard, my name is Shah. I was one of those kind of rare folks who knew what I wanted to do at a very early age, and that was I wanted to be an engineer. I knew from the very moment I kind of knew what technology and engineering was, that's what I wanted to do. So you see, even in this picture on the right, this is me at a science fair doing stuff about satellite dish directional controls, which is sort of a like a preface to what I ended up actually going to school for and working in, and that's actually satellite propulsion systems. So when I went to school for engineering, I studied chemical engineering, and the first job that I got out of school was with Boeing Satellite Systems down here in Los Angeles. That's where I'm based. And so I was working on all aspects of satellite propulsion systems. We worked on liquid propulsion, we worked on xenon ion propulsion, lots of really cool stuff. And I actually did that for 11 years of the start of my career, which really cool. Ended up putting up 12 satellites that are currently orbiting the planet. One of the ones that I worked on is actually at the top of this rocket you can see right behind me. But unfortunately, that is one of the ones that didn't actually make it. So that satellite is now sitting on the bottom of the ocean in a bunch of debris. But the rest of them are up there. Very cool and exciting work. But while I was at this kind of general corporate engineering job, I always felt like I wanted to do more with the skills that I had. I knew that, being an engineer is a very interesting skill. There's a lot of amazing things, as everybody who's in this hackathon right now knows, like that you could do with engineering. You could solve problems. I mean, engineers have helped to solve, pandemics. They've helped to solve hunger and all sorts of issues all across the globe. Leonardo da Vinci was an engineer. So there's a lot of amazing things that engineers can do. So the first, way that I tried to use my skills for better was working with an organization called Engineers Without Borders. So I did that for a number of years, worked very closely with the Los Angeles professional chapter. I was a president for a bunch of years. And this is a project that we did in southern Tanzania around drinking water for a school in the highlands of Tanzania. It was a incredibly rewarding work. And it kind of inspired me at a very early age that there's more that I could be doing with my expertise. So that actually led me to go back to school. So I went back to school a couple times for engineering, but with the mindset that I was going to try and find something that I was very inspired by to help with. So I went to USC, I went to Stanford, and it was actually at Stanford where I started working with an organization called the Center for Ocean Solutions that looks at issues around conservation, ocean conservation, and how to solve those issues. And that's when I started understanding how bad things were with respect to the planet, and kind of the need for people to start to create better solutions around protecting the planet, preserving the planet, helping to stop illegal activities like poaching across the globe. And this was something I was very excited about. So I started doing a bunch of research at Stanford around how do we do that? How do we bring in the things that I know, which are engineering and technology, and put that into something that I thought could use some help at the time, and honestly could still use some help today, which is conservation, wildlife conservation. So that's work that I did on a research basis for a number of years, and one thing led to another, and National Geographic kind of heard about that work that I was doing. And this was back when they had this program called the Emerging Explorer Program. And so in 2013, they made me an Emerging Explorer around this concept of conservation technology. And then in 2016, I became a fellow, kind of helping to think through what conservation technology is, how does it fit into the bigger picture of wildlife conservation, and how we could use those things to do some really good work in the world. So I've done some amazing stuff with National Geographic over the years, gone on expeditions to incredible places, which I'll tell a little bit about today. But the greatest thing was that Nat Geo really saw this opportunity in this space that was just starting to be explored around how you bring the engineering and the technology field, which typically was like something that people did not think about when they thought about conservation. Obviously, technology was used in conservation, but it was things that were, very expensive or off the shelf or brought over from other industries. And there wasn't really this idea about how do we design it with conservation as the core user. So in 2015, I actually started a nonprofit called Conservify, which is based in downtown Los Angeles, which typically isn't where you think would be a hotbed of wildlife conservation, but it allows us to do a lot of really cool stuff. There's lots of engineers here that we work with, and we work on projects all over the world. So this is what the lab looks like right now. I'm actually in it, so you can see the kayak and the drone behind me. It's obviously empty right now because it's a Saturday, but also because we're living in this kind of pandemic where everybody's been working remotely. But typically it's full of Conservify employees or partners that are actually working on projects using things like our 3D printers and laser cutters to do some phenomenal work. So why are we focused on conservation? This is something that I probably don't have to tell a lot of the people who are listening today, but we're effectively failing when it comes to conservation. We're not doing a good job. We're seeing, an extinction rate of species that's 1,000 times above what baseline extinction rate should be. We're watching them disappear before our eyes, and we really need to bring more tools into how we do this stuff to try and better change behavior, better change the incentives around things, and create tools that are more accessible and available to the people who are actually on the front lines doing this sort of work, which is kind of a thing that I'm very, very passionate about, is creating those sorts of tools. So conservation technology as a whole kind of operates in two different modes. This is from a fantastic paper that some colleagues of mine wrote. Typically, the way that it was done in the past was more of an opportunistic level. So basically, the military is using this technology, industry is using this technology, let's bring it over and try and use it to save rhinos. Which is a great way to work, but maybe not necessarily super sustainable. And the new model is where you're designing these technologies as conservationists, like they're the core users. We're doing the same kind of product design methodology that you see electronics companies do or consumer companies doing, but we're doing it to try and solve this problem. And this is the area that Conservify sits in, is we're trying to do exactly that sort of thing with a lot of the products and the ideas that we come up with, which is what I'll talk about. One thing, we're a nonprofit. Everything we do is open source. So any of the technology we develop here, we build here, we deploy here, it's just open for anybody to use, modify, do whatever they want to do with it. The data that we collect, we really push it for it always being open data, because one of the things that we're constantly trying to work against is this idea that data is collected in these really remarkable high biodiversity areas, and then it goes back to academia, or it goes back to some company, and it stays in these silos for a very long period of time and isn't allowed for the people who actually live in those communities to monitor it and understand it. And so open data is a huge part of this puzzle. Additionally, since it is open source and we're trying to make these tools accessible for a lot of people, we do a lot of STEM work, a lot of outreach. And so how do we create tools that are both going to be effective for, a ranger in the middle of the Republic of Congo, but at the same time, we can turn around and have some high school students try and develop these same sort of tools to understand them more. Part of this is because I want people to be excited about this, and I want to bring in more conservation technologists into the future. So I do things like this, a lot of virtual class meetings and in person back when we were in pre-pandemic days. But I think it's really important, the things that you develop, to go back and try and show the younger folks about it, and like get them to be inspired about that. And I've just had the most amazing feedback from people who are able to kind of explore these sorts of things. So in building conservation technologies, we've really thought a lot about what's the right way to build it. And as you guys are going through these projects, you're probably thinking about the same sort of thing. And it's really important for you to understand the people who are going to be using these tools, for you to have empathy for that, and to help to identify some of like the needs and the gaps in those areas, to try and fill those gaps. That's where we find the most impactful projects that we work on to come out of those little gaps. And then it's critical to prototype quickly, test assumptions quickly, and to do that stuff very carefully. There's a lot of projects in this space that maybe have been very ambitious and didn't do the right kind of testing. And the fear is, when you bring in a new solution to people who maybe aren't familiar with that sort of solution before, they don't know the ways that it could fail. And any good idea, any new idea, has tons of failure around it. So you have to understand how you can fail in a way that's safe and doesn't actually just cause issues to the idea in the long term. So we iterate and pilot quickly in a way that we try and be as controlled as possible, so that when we're finally putting the solution out in the world, it's going to be successful, and it's actually going to solve the problem we're trying to solve. So some of the things we work on at Conservify, we do some work around animal tracking. So animal tracking is an important part of ecologists understanding the movement of animals and where to put protected areas. But up until very recently, these animal tags were very expensive, costing thousands of dollars. And then it's very difficult for scientists outside of places like the US and the UK to actually make use of these tools. So open source animal tracking, ways that you can understand and monitor behavior in the ocean by using acoustics or smart buoys. So we've worked on some projects with that. This is a prototype that we're doing with it. We did a few years back with an organization called Rainforest Connection. Fisheries monitoring. So, fish is actually very important to the world. It's strange in that it's a food source that's entirely wild. So, we catch these things in the wild and we bring them back. So, but that means that we can have a lot of impact on those ecosystems, and to understand those impacts and how we could still provide protein to the billion people around the world that rely on ocean-based foods as their primary source of protein, but do it in a sustainable way. So we think a lot about those sorts of things. And drones. Drones is something that I have been working on for a long time. I've been working on drones for as long as before you could actually go out and buy things from companies like DJI. When you had to hack together RC airplanes and microcontrollers to try and figure out how to make these things work. It's actually my first grant from the National Geographic Society was around that. It was around this project that you see right here, is like, how do you use drones for coastal protection and coastal monitoring? And that project was actually interesting because, in the beginning of it, it made more sense to build the drone yourself, but by the end of the project, it just made more sense to buy it. So we've done a lot of projects around drones. Our most recent one is work we've been doing with this fantastic organization called Ocean Swell in Sri Lanka, where they do a lot of ocean conservation work, monitoring of this very unique blue whale population that they have off the coast there. And we flew drones down there to try and understand the health of the whales and monitor the interactions between the whales and the whale watching industry that was happening there real time. But one of the projects I'll talk a little bit about in further detail is a project we have, an ongoing project that's in the Republic of Congo in Odzala National Park around monitoring for Western lowland gorillas. So we went there to help some researchers that have been doing behavioral studies that were basically using camera traps to try and understand this very unique behavior that these gorillas had, where they would find this certain type of tree and eat this fruit. And it's interesting because that was not a natural gorilla behavior, it was a learned behavior, and these researchers wanted to see how that knowledge is spreading through those communities. So I came in to map the forest because we knew the gorillas were very interested in this specific type of tree. So we mapped it in 3D, and then we worked on trying to build some models to try and identify where those trees were, so that they can be a little bit better about where they're placing these cameras and doing these sorts of things. So that's something that we have an ongoing project with, and we're evolving one of our field kit projects to support, which I'll talk about in a little bit. Another area there's a huge amount of opportunity, and this is sort of where my focus has been in recent years, because I'm very, very fascinated by this. It's the area of creating low-cost sensors. So there's a huge amount of amazing work that's happened in the IoT space and the Internet of Things space around how do we create these low-cost sensors to do some cool stuff. So if you think about the way sensors were made before, when it came to scientists that would use them, it was usually that top process. So you have these scientists that have this interesting scientific question that they want to ask. The principal investigator of that science will develop that tool, or partners of theirs will develop the tool. They'll try and integrate it with the existing tools that they're using out in the field. They'll test it in their lab, and then they'll deploy it, deploy it in some way that typically is very expensive to deploy. This process makes something that tends to be more expensive, tends to be very inflexible, and it creates something that's just kind of stuck in space. And there's a lot of science today, even in the climate world, that's built on tools that were structured and created in this sort of mechanism. What we try and do is we try and use what's happening in the IoT space, what's happening in the wearable space, all these sort of electronic space to answer scientific questions, but use that process. So how do we create, how do we do the same sort of user research? How do we understand what those requirements are, rapidly prototype around those requirements, test a lot, often, all the time, and then deploy in a large scale way. And this is the context that we are building our field kit idea around. So some of the sensor work we've earlier done, one project was in Banff National Park. This was working with some data artists, some researchers from the university in Edmonton, and Parks Canada, and we're looking at how do we monitor the melting of a glacier. So you see that glacier in the picture right there is Bow Glacier. It's actually very interesting because it's an important glacier because it feeds a river that runs all the way down through Calgary, and our funding for this project came from the city of Calgary. So we ran a bunch of tests. We were like understanding seismic monitoring and how we could build low-cost seismic monitors. These are some of the early tests that we did. But we ended up designing a solution based off of this, like low cost. How do we leverage things, utilize things in the space that we know we could build as reliable? This project makes use of things like Raspberry Pis, which I know a lot of you guys have used in the past. And then we did a big expedition where we went and we took them up to the glacier and we deployed them. And so this is the kind of the what we call the glacial observatory, where the sensor data comes back and is streamed real time. So the cool thing about this project is the data comes back live. It's real time. So if any of you guys are ever in Calgary, you can actually go to this park called Brookfield Plaza, and that's designed like the glacier, and you can actually see the data from this glacier be translated into lights and sounds throughout that ecosystem. But it's an interesting way to look at how you can take data that is both scientific but also make it artistic and create a public information tool out of it. So, but a lot of our sensor work really originated in this project that we had for a number of years with National Geographic in the Okavango Delta. And so this project was, the Okavango Delta is this fantastic place in Africa. It's in Botswana. It's one of the most healthiest ecosystems they have there, home of more African elephants than anywhere else in the world. But it has all that charismatic megafauna that you think about when you think about Africa. So we're thinking about how we could build sensors that we could deploy there that could better understand and monitor those things. But the other thing we were thinking about is how that data is also communicated to public. And so we worked with a fantastic person named Jared Thorpe in this organization he was running at the time called the Office for Creative Research around how to take that data and visualize it in a way that is interesting and compelling. And the site isn't live anymore, but when it was this site where you could actually go and explore the data that we were collecting real time on expedition and sharing with the world. And that's all sorts of things: sensor data, it was images, audio, all like everything that you can think of around these expeditions, but make it all open, make it all available for anybody in the world to do that sort of thing. So a lot of people were really excited about this project, and it kind of inspired us to come up with this idea that we had that's called FieldKit. So FieldKit is actually something that we're launching to the world this year, but the idea behind it was, we need to have better tools that allow anybody who wants to measure the world around them and take action and be empowered by that. So if you think about the sensor space, there's a lot of custom scientific one-off equipment on one very far end of the spectrum. That stuff's very expensive and really only accessible to wealthy companies, well-funded universities, things like that. And that's what a lot of the science is actually built on at the moment. But at the other end of the spectrum, you have a lot of fantastic projects of people working on things like Raspberry Pis and Arduinos, but a lot of times that data isn't seen as scientifically relevant. And you also have these consumer-grade IoT projects that have come down the line where they're looking at how do we build commercial products for monitoring smart cities and things like that, but they're maybe not going through the same sort of scientific rigor that the one-off stuff does. So we thought about FieldKit as building something that bridges that gap. How do we make use of the low-cost stuff that's happening in the Arduino, Raspberry Pi, and consumer product space, but at the same time integrate the sort of processes and accuracies and fidelity and understanding and everything that you see in the scientific space. And if we do that the right way, which is what we've been working on for the last couple of years, you could still do it at a price point where scientists in the Peruvian Amazon can afford it. You can have high school students in Southern Europe that can afford it. It just becomes accessible to a lot of sort of people. And that's what we've been building with FieldKit. So we're trying to create something that is as useful to field scientists and conservationists as it is to environmental justice activists or citizen scientists or teachers and students and things like that. So over the last couple of years, we've been deploying prototypes of FieldKit in a number of different situations. We have a big project with the Wildlife Conservation Society and Florida International University, where for their citizen science for the Amazon project, where we're actually working with local scientists and indigenous communities to do water quality monitoring, weather monitoring across the entire Amazon basin. This is 5 of the countries that make up the entire Amazon basin that we've been working on this project with. We have a project with the American Prairie Reserve and the Smithsonian to put FieldKit throughout this new type of reserve that they've been building at APR, and ways that we can kind of help the researchers there better understand how to take an ecosystem that was originally used for farming and ranching and turn that back into a wild ecosystem that's accessible and available for wild animals. And then, most recently, actually, I was here in December, right before all this stuff happened globally. We've been working with UCLA on a NSF-funded project around the Congo Basin Institute. So, they're looking at how they can create these research stations throughout the Congo Basin. The one that we're working in was in Cameroon, and create these kind of open sensor networks that allow anybody who's doing research in that area to bring back data and use that data in any sort of way that they want to do. So we actually created a radio network in the Shah Reserve and deployed a bunch of sensors out there that are being used to kind of monitor different things that the scientists are really interested in that area. But the important thing about this effort is and I would even say the efforts before it is that they're really engaged with indigenous communities in that area and how we're creating tools that are not only useful to scientists, not only useful to conservationists, but also useful to the people from those areas originally, the communities that grew up there, the people who are trying to learn and understand and improve those different areas. So kind of what FieldKit is, first of all, it's completely open source. So anything I talk about here, anyone who's listening can take this, can modify it, can create their own version, can do whatever they want with it. But we're building FieldKit as three things. We have a data visualization website, an app, and a bunch of hardware we're creating. So first I'll talk with the hardware. I have some hardware over there. I didn't actually bring it over next to me, but basically they're data loggers, they're sensor modules. There's a bunch of stuff that we've been developing, communication modules, a whole ecosystem of hardware for people to be able to use it. And the idea is that you can kind of just plug in whatever you want to measure. This is something that's actually very difficult to do right now with the scientific hardware out there. If you want to just, for some reason, attach a weather station to a pH meter, you can't do that very easily right now without knowing a lot of coding. But with FieldKit, you can just plug things in and really understand it. But one thing that we really want people to be able to do is create their own modules. So, my team here isn't going to be able to create everything that we want to create. And there might be some interesting use cases that people want to take this open source hardware and create it. And so we're here to help and support and do whatever we can to do that. Here's some pictures of some earlier editions of the hardware, but yeah. And then the app, really the idea behind it was, if you think about hardware and think about your ideas. So as you guys are developing these ideas, you have to think about ways that people are using it and how you can create better mechanisms for ease of use. And so one way we do that is apps. Everybody knows how to use an app. And if you could create an app that allows you to interface with the hardware, change configurations on the hardware, and then at the same time, you can also help to lead good behavior. So if we know that there's certain information and metadata that needs to be collected around a scientific deployment, then we build that into the app so that people are able to kind of follow through and use that and gather data that scientists can use, gather data that decision makers can make decisions based on, regardless of who's doing it, students or anyone. And then a data visualization that allows you to kind of explore, share data, push it to anything that you want to end up doing, like as flexible as possible is really the idea. But one thing we're trying to do as part of this is create this open source sensor library, open sensor library, where the idea is that all the knowledge that we're gathering from doing all this development and effort, we're putting it out for free for anybody to take. It's going to be a wiki that's online that anybody can kind of contribute to or do interesting things from. And then, as I said before, all the data is open, it's accessible, it's reliable. How do we make it so that it's responsible, it's trustworthy, and then that it has this longevity to it? So we have a bunch of deployments. I won't get into this. I kind of wanted just to spend a couple minutes talking about my journey and what I think all your journeys should do. So I was very lucky in that I found something that I was passionate about, which is the environment. And I found something I was good at, which was engineering and technology. And I found a way to merge those two. And I think that is an important thing for you all to think about. There's opportunities out there that exist for things that you're excited about, whatever they end up being: civil rights, environment, food security, any of these sorts of things that you find some sort of passion about. And then whatever your skills are, engineering, graphic design, communications, anything that your skills are, there's ways that you can merge those two things together. And you should think long and hard about how you can do that. You can find work that's both fulfilling and making use of what you're actually good at. The other thing I would add is, always think about how you can grow your skills and think about that path. If you want to be able to understand how you can fit into this future dream job later, what sort of skills do you need to know? How can you work with people, volunteer your opportunities, take on mentors, do all these really important things to get to a point where you're actually knowledgeable enough about that you can actually stand up and do some really phenomenal work around this. And so this whole learning process is a lifelong process. It's something that never ends. And so think about how you can continuously grow your skills in that area. The last thing I would add is to just constantly keep on exploring. Like, the one thing about my work that has been a constant is that I've failed at so many different things, and I just didn't let that distract me. I always kept that curiosity and that excitement about finding what was next. And if it was something that I found out didn't work, I would very quickly kind of pivot to something else and see if that would actually work. And this is the kind of thought that you guys should think as you're building out what you want your future to look like. I think it's a really important thing to kind of focus on. So, here's some of my information. If you guys are interested, please reach out to me. I love hearing from people. If you're interested in helping with the stuff we do with FieldKit or Conservify, or even have any just random questions, you can always ping me on social media or send me an email. But best of luck in the work that you guys are doing over this hackathon. It's fantastic that you're spending your time trying to think about solving something better. So I wish you all the best on that.